Hello, YouTube. This is UMails03. We're now on to lesson 37 in the Java curriculum. And so this is the very last lesson that we would really be saying anything about object-oriented programming in particular, as far as I can see. There are about 5 or 7 things left that I wanted to talk about, 5 or 7 different lessons to give. And what I wanted to shift focus to in the videos to come is called sorting algorithms and searching algorithms. So different ways of sorting an array or an array list, a data structure that has elements that can be sorted in it. But what I thought we could do first is essentially review everything that we've said in regard to object-oriented programming. So now what I'm going to do is open up the waiter class, because we've been talking about all this architecture where first we had a person superclass and we built that from lessons 22 to 24. And then in lessons 31 and 32, we were looking at doctor and student, which were concrete subclasses of this concrete superclass. And then in lessons 33 through 35 and then into 36, we talked more about the abstract version, where basically the same thing happens. The only thing is that this person superclass is no longer concrete, and we would replace that either with an abstract class, which is allowed to have concrete methods, or an interface, which is not allowed to have concrete methods, but neither an abstract class nor an interface can be instantiated. The only thing you can do with an abstract class or an interface is declare that the object is of type abstract class or interface. If it is, then it only gets to use these 4 methods, however they're defined in the subclass, but it would not be able to use any methods that are defined or seen or recognized for the first time in the subclass if you declare an object of the type superclass. In this case, we're talking about the abstract case, but the same thing happens for person. If you said person X equals new doctor, you would only be able to use doctor's implementations of methods that were first seen in person. And the same sort of thing works for abstract methods and interfaces. So hopefully you can feel comfortable either feel comfortable with that content or know how to navigate back to it and review it. So we're going to go ahead and review some of the object-oriented fundamentals, and then I wanted to talk about one of the sorting algorithms. So with this lesson, we'll talk about the simplest sorting algorithm. The code for it is very simple, but for Java, it's the most work. So normally we're going to have this trade-off between code that makes sense for us and then really the process for Java and what's actually the complexity, what's the efficiency for the program at the end of the day. Because honestly, Java could struggle with a simple method much more than we could conceptually. So for example, with lesson 22, we were talking about how we declare private instance variables at the top of a class. And we need to add a constructor, which assigns values to the instance variables. And then we'll also have public and getter and setter methods, which respectively return and modify the values of the instance variables. So obviously these usually have a return type, and these are obviously usually void. And then with a separate tester class, we can call the instance methods after creating instances of our object using the constructor that we made, passing in the parameters according to how we designed it in the constructor. And so we can call those methods to make sure they work. And then in lesson 23, we took it a step further and we said different constructors allow you to pass in different sets of inputs during object creation. And having a toString method will override object's toString method, as we said more recently than that. And so it'll allow you to come up with your own string representation of what it means to print an object. So you don't even have to call .toString on a person object. You could just try printing that person object and you would see whatever string is implemented in the toString method and returned there. In lesson 24, we talked about the keyword this, which distinguishes between an instance variable and a parameter. It's required if they're if their name's the same way, it's required, but if their name's differently, then it's just optional, then it's whatever. Public methods are accessible to classes outside of the class in which they were defined, but private fields are only accessible to classes inside the class. And then static methods are called directly on a class, for example, integer.toString of 20. But then if you have instance methods like person A equals new person and then a.getName, that would be an example. System.out.println of a.getName, that would be an example of calling an instance method. And then we said that we can also have 1-dimensional and 2-dimensional arrays of objects, just like we had arrays of primitive data types in previous lessons. And we talked about when we have an array list, which is the next data structure, a resizable dynamic array, we can only pass objects into it. So in lesson 26, we talked about different object-oriented representations of data types that we used to think about in primitive contexts. So the idea of an integer object or a character object. And then in lessons 27 and 28, introducing the methods of array lists so that we could go ahead and have array lists with instances of our classes in it. So it's an object-oriented perspective of basically adding person objects or student objects or waiter objects to an array list as long as they're all the same data type. We can add instances so Java docs is formal Java documentation that includes descriptions of the operation, parameters, and return values of each method and constructor. So we talked about how to do that. Recursion occurs when a method calls on itself. This serves as an alternative to iteration, which uses a loop to repeat code. We talked about inheritance, which occurs when a subclass inherits a superclass, receiving all of its functionality and optionally making its own or changing the functionality that it inherited from the superclass. Polymorphism occurs when an object is declared as an instance of the superclass, but instantiated as an instance of the subclass. And if you do that, you can only use methods that were defined in the superclass. But if the subclass modified any of those methods, it'll use the subclass's versions as long as it was instantiated as subclass, okay? But if it's declared as superclass, only the ones that you at least first saw in superclass can be called. And then when in lesson 33, we talked about how a method or variable that is protected is accessible only in that class and any subclasses of those subclasses. And a final variable can be initialized but cannot be changed. And a static variable refers to a class variable that pertains to the general class as a whole rather than a particular instance. 3 more lessons, we talked about an abstract class being a superclass with concrete and or abstract methods, but we cannot instantiate it. If we have an abstract method, that means it only has the header, and any subclasses would have to provide full definitions. The subclasses of the abstract class can also provide, modifications of concrete methods that were concrete in the abstract class, and or they can add their own methods, but those are just optional. And polymorphism, an object declared as an instance of the abstract class, that's okay, but it needs to be instantiated as an instance of one of the concrete subclasses. And then an object declared as an abstract class can only use methods that were concrete or abstract methods in the abstract class. And then same thing kind of happens for interface. The only difference with interface is that we don't allow concrete methods. And so all method functionality would have to be totally specified in those classes that are implementing the interface. And so polymorphism, you can declare something as an interface, but obviously you'd have to initialize it as an instance of the concrete subclass of the concrete class that's implementing the interface. And then an object declared as an interface can only use methods that were abstract methods in the interface, only ones that were flagged as, being defined later on in the subclass. And then lesson 36, we said we can modify calls to the constructors of the superclass, mixing and matching the inputs, in particular constructors with super, right? If you don't have to call super of NA, even if you're feeding in a name and an age, right? You could just call super, and then it's just going to use the default values that we had in that, default constructor from the person class, which I think was like Jim and 61 or something. But you can neglect the parameters that the programmer passes in if you want to, and you can mix and match, right? We multiplied the age by 2. We concatenated the name with itself. So that's just some examples of that. And then remember, if we call super.f of a, that would return the superclass's version of the output of function f if the input a is applied. And so a would be like a parameter in the subclass method. And we say, oh, we'll just go ahead and run the superclass's version of f with input a. And then you could modify it or something if you want, or you could just return it. But if you're just going to return it, then there's no need to modify that method in the subclass. And then for a void method, you would just call, for example, super.f if it didn't accept any inputs. Super must be the first line in a subclass's constructor. And the comparable interface mandates a compare to of object-o method, which allows us to compare instances of our class. So I wanted to show you one more example of that, but we'll talk about a few new things in this video. But what I'm going to do is, remember, in our person class, we said that we're going to implement the comparable interface. And we saw in the Java API that the comparable interface requires us to supply a compare to method, which accepts an object and returns an integer. And so what we do is, assuming we're comparing two person objects, it's called on a person instance and we're passing in another person instance, we need to go ahead and explicitly convert it to a person object, that P that's coming in. And so now we're going to call the person form of it Q. And so we just go ahead and compare the length of our name with the length of their name. And so if our name was longer, we return +1. If it's shorter, -1. Otherwise, we return 0. And that's that. One of the things I'll say about the way that return statements work is one of the things that we said with break is that if you ever get to a break, the code stops. So if you say something like if Boolean break, and then you just have code under that basic if statement, if that Boolean is true, it breaks out and it does not continue. So it would basically have the same effect as if you said if Boolean break, otherwise do all this other stuff. So you actually don't need to say else here. Once you return a value, the method is considered complete. But you have to supply return cases and all the possible things that could happen here, right? So if this Boolean's true, it returns 1. If this Boolean's false, but this one's true, it returns -1. If both of them are false, it returns 0. So hopefully you can follow that. And then that's a totally valid method as long as we fix the braces there. So now that's kind of what we have going on here. And then we could have a different compare to method, for example, in our waiter class. So now what I went ahead and did is I actually, in this waiter class with all these review notes, I actually implement, not only are we implementing the occupation interface, which is the interface that we made in lesson 35, but we actually also implement comparables. So it's totally legitimate to implement more than one interface. So now if you scroll down, we would need a compare to method. So if you're talking about comparing two waiter objects, you could say waiter other waiter equals waiter of T. And then what you could do is you could say, and then so this one, when we made our waiter class, we said we weren't really going to worry about instance variables and things like that. So this one would be a little different from the compare to method that we made for the person class when person implemented comparable, because person had instance variables. But for these two waiter objects, what I did is I said, I'm just going to declare and initialize two ints on the same line. And in lesson 19, we talked about the math class, and we said that math has a method called random, which returns a random number between 0 and 1. And so if you multiply by 10, it returns a random floating point number between 0 and 10. If you convert it to an integer, it would be like 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, each with 10% probability. So that's what's going to happen. And then it's just going to look at my waiter's number, which is just the first random number that I calculated, and the other waiter's number, which is just the other random number that we calculated. And so if the first one that we calculated is bigger than, this other waiter's random number, just the second run of the math.random, then we would return +1. Otherwise, -1 and return 0. One of the things I want to say about methods that return values is just because a method returns a value doesn't mean that it's not allowed to print something. So when we were talking about different types of static and instance methods, we said typically a method that returns something will do just that, right? And it wouldn't print anything. Usually the methods that are printing something are the void methods, right? Because if they can't return something, if a variable can't be set equal to the result of a function, then hopefully the function would be able to do something if it's not going to return a value. So that's an example of void. But it turns out that return methods can also print things. So every time we called the compare to method, every time we said system.out.println of a.compare2 of b, not only would it return this int down here, but first it would go ahead and print these two things, because just the nature of calling the method prints these two things, even if you just did a variable assignment. So even if you just said int x equals a.compare2 of b, where a and b are waiter objects, even just making that assignment, it's not going to print the value of x. You're not going to get a 1 or a -1 or a 0, but you are going to get my waiter's number and the other waiter's number. So let's go ahead and try that out. So remember that this compare to method, we needed to make it, and we need to pass in an object, a general object, because that's what's mandated in the comparable interface. And then it returns an int. That's what's mandated in the interface. And so what we do, remember, we created a waiter object, which is just an explicit cast of this object that's coming into the method into an actual waiter. And then we just compared two random numbers, and we said that if the first random number that we make is bigger than the second, return +1. If the first one's smaller than the second, return -1. And we said we don't need an else here, because once we return something, the method's considered complete. So it like wouldn't even go down to this code down here and return 0 anyway. It only returns one thing. But we said that if a method returns something, optionally, if you want, it can also print something. So even just doing an assignment, even just calling this method, calling it, just setting something equal to the result of the compared to method would cause these things to be printed. So what we're going to do is we're going to go ahead and go into occupation tester. And I want to go ahead and show you some things. So essentially what we're going to do is we're going to say waiter y equals new waiter, and then z equals new waiter. So it just declares and instantiates, declares and initiates two waiter objects on the same line. And so now what if you say int a equals y dot compare to of z? Okay, so now what happens is if you go ahead and compile this, it doesn't really look like anything is going to be printed, right? The compare to method returns an integer, and we just went ahead and assigned the value of a. But now if we go ahead and run the main method, it goes ahead and tells us what the random numbers we got are. And those just happen to be low, but if we go ahead and run this again, we could get different results. So here we got 2 and 1, right? And then you could run it again, and you get 6 and 6, right? So those are just random numbers between 0 and 9, integers. And then you could go ahead and print system.out.println of a. But every time you say dot compared to in your code, it would print those 2 lines of code. So I just wanted you to be familiar with that. But this is another example of compare to. And so you cannot implement the comparable interface unless you have a method in your code that returns an int, is called compare to, and accepts an object. And then you would go ahead and cast that object to a particular data type, you know, the specific one that you're looking at. So here it would be a waiter. There's one other keyword that I want to talk about in this video, and that's called instance of. So there's essentially a field called instance of. It's not exactly a method, but basically it kind of works like a method. It returns a true or a false value. And so what we're going to do is we're going to say waiter y equals new waiter. So let's remind ourselves of what architecture we have here. So remember, waiter is a concrete subclass, and it implements this occupation interface. So I don't know, maybe we wouldn't say it's a subclass if it's implementing an interface, but you can sort of think of it, right, as a subclass of this abstract class, right, this occupation that we're not allowed to instantiate. But what you can do is you can say system.out.println of y instance of waiter. And basically what the instance of keyword does is it'll tell you if y is an instance of either waiter or any subclasses of waiter. So let me show you what I mean by that. We're going to go ahead and compile it and run it. And then if we say, it would say true, because it was instantiated. This waiter here is a subclass of this word right here. Okay. And so if you went ahead and said object, then that would be okay too. Because remember, waiter, it was instantiated. Now we're talking about what it's instantiated as. So it's instantiated as a waiter. So if you say object y equals new waiter, it's still an instance of waiter, even though it was declared as an object. So here, that would be okay. Okay, same thing with you could put an occupation in here. Okay, what if you put occupation? Because essentially, what happens here is that waiter is essentially considered as implementing occupation, being basically a subclass of occupation. So if you say y instance of occupation, you're not allowed to instantiate an occupation. But since waiter was instantiated as a subclass or something that implemented occupation, then this is totally legitimate. Okay, so but if you say y instance of string, then of course this would be a problem. So what you could do is you could go ahead and run that, and you would go ahead and have an issue there. So hopefully that's clear to you. And then it's not really a method or anything, but you could, yeah. So that's essentially what you have going on here. So in the next video, we'll probably actually have one more video on object-oriented programming, because I wanted to tell you about an array of abstract classes or interfaces. So it turns out you could actually have an array of occupation objects. Okay. The only thing that you couldn't do is pass occupation objects into it. Okay, so you could never say, so this is a perfectly legitimate array, because even though occupation is an interface and you're not allowed to instantiate it, it turns out that you are allowed to instantiate an array of the interface or abstract classes. But then if you go ahead and say jobs of 0 is new occupation, you can guess that the issue is going to be there. So at that point, you'd go ahead and change this to lawyer. So it's going to go ahead. We're going to go ahead and say a few more things about that. There's a few more things we can say about object-oriented programming, but hopefully the first 6 or 10 minutes or whatever of this video gave you a good review of all those fundamentals that we've been talking about for 14 or 15 lessons, because after the next lesson, there will be basically little to no further object-oriented programming, and we'll shift our attention instead to sorting and searching algorithms and throwing exceptions and maybe 1 or 2 other things, and then that's it. So from UMills03, thanks for watching, and please subscribe.